Hallo?
Dann kommt ja erstmal. Good morning to our audience in Latin America. Good afternoon to all participants in Germany. I would like to give you a very warm welcome to the second conference day of the ExpoVirtual Energiewende América Latina. Today we will speak out about energy efficiency. My name is Silke and I'm working as a consultant at the Energiewende company, which is located in Berlin in Germany. Energiewende is a consulting and service company with national and international activities. Our services include the organization and management of expert seminar and conferences, the development of investment and marketing strategies for international businesses and export activities, as well as creative networking and communication solutions. All of our work is dedicated to the environmental and energy sector, with a special focus on sustainable energy solutions. We are delighted to host this virtual conference today, which is part of the digital fair ExpoVirtual Energiewende América Latina. The ExpoVirtual dedicates to an international exchange about energy transition. We want to achieve an energy future that is environmentally friendly, secure, and economically successful. Energy transition is a joint effort on a national but also an international scope. We have joined forces with the German Chambers of Commerce in Latin America, as well as with many other important associations and cooperation partners to foster the international exchange on the energy transition worldwide with the ExpoVirtual. Next. And now it is time for us to say thank you once again for supporting our mission and for being with us. We really appreciate your support. We also want to say thank you to our premium exhibitors from Germany and from Latin America. In the coming days, you will have the chance to explore the fair ExpoVirtual Energiewende América Latina. With this international fair, we want to provide experts from around the world the possibility for knowledge exchange, business development, and most of all, give you a platform to make personal contacts. In these times, traveling has been difficult, but still, we want to give you a platform to reach out to each other. Even though you might miss the normal chatting and a conference with a cup of coffee in your hand, take the initiative and visit our exhibitors at their booth. Take your coffee, go to your screen, and pass by. Everybody is ready and waiting for you. We have 5 pavilions. We have 5 pavilions. They're like the green energy pavilion, the solar and storage pavilion, energy efficiency, the environment and infrastructure pavilion, and the global hub. The team of Energiewende is for you available also in the global hub. Today's conference theme is energy efficiency. And we think that the energy transition is based on 2 pillars. It's energy efficiency and also renewable energies. I would like to point out the particular importance of this topic of today, because we all know the cleanest and cheapest energy is the energy we don't use. We are glad to have the topic reflected within the conference today, but also with our exhibitors. Our exhibitors provide the solutions to help you save money, but also to protect the environment. For example, with industrial solutions like automatization solutions, monitoring solutions, measurement devices, moisture control solutions, ventilation systems, and also heating and cooling systems based on electricity. Please be very welcome to check out the exhibitors of energy efficiency. As I said before, for an international, successfully energy transition, we need joint forces. So I'm grateful to present some actors from politics, business, and research today in the scope of this conference. 9 speakers from Colombia, Guatemala, Costa Rica, and Germany will share their expertise on energy efficiencies in buildings and industry with us. We are extremely thankful and proud to have you here today. Before we start, I would like to give you some last organizational advice. We would like to encourage the audience from around the world to take part in this conference. Please feel free to use the chat box and send us your questions. After every presentation, we will have a quick session and read them out to the speakers. Now, I would like to introduce our first speaker. I'm extremely honored to announce His Excellency Hans-Peter Knudsen Quevedo, who is the ambassador of Colombia to Germany.
Thank you, Silke, and thank you, ExpoVirtual Energiewende Latin America, for this invitation. It's a very important event, and I'm very glad to start today in the second day where you are going to speak about efficiency first. Because speaking about efficiency means speaking about costs. And speaking about costs is speaking also about competitivity. And competitivity is a very big issue, especially in this time of the pandemic, and will be very important in the recovery post pandemic. But also, the challenges of the post pandemic recovery are united with the challenges due to the climate change. So that when you see the topics you are going to discuss and present today, which includes not only climate change, energy, but also, for example, architecture and buildings, you see that you will have today a very interesting day. In the case of Colombia, we are speaking a lot about renewable energies. And as you may know, the energy matrix in Colombia is a very clean matrix, but we are working a lot towards increasing the share of renewable energies. And together with Chile, we are working with Germany very hard towards green hydrogen. I know that my very dear colleague from Chile, Ambassador Maquena, spoke yesterday about this topic and the experience between Chile and Colombia. So, thank you very much for the invitation, and I hope that you have a very successful day, a very successful evening here in Colombia with such interesting topics. Thank you very much for the invitation.
Thank you, Your Excellency, Mr. Knudsen, for this very nice introduction and also giving some insights on Colombian projects on hydrogen. I think this is a very important topic, and I'm sure it will be followed up upon other speakers within the scope of this conference. Now, I would like to introduce our first speaker of session 1, which is dedicated to energy efficiency in buildings. And this is Dr. Simon Schmidt, who is the head of the Department for Hygrothermics from the Fraunhofer Institute for Building Physics in Germany. Mr. Schmidt, I hope you can hear me. I would love you to turn on your camera.
Yes, I can hear you.
Perfect.
I have turned on my camera, and now I try to start my presentation, if that is possible, that you let me share. Good. So here we go. So also thank you from my side to invite me to this virtual conference. Actually my first conference in the virtual realm. And my topic is, as you said, the energy efficiency in buildings, and I'm glad that I can see in the topic itself the framework, energiewende, because that is also the basis of my presentation for today. And I would like to take you within the next 20 minutes to a journey through all what we have experienced in Germany in that realm, energiewende. And bringing that then to the end also into the realm of the possibilities of bringing that also to Latin America. So, and let me begin in that journey to state something about the basics of the energiewende, which we have in Germany. These basics are mostly on 4 political objectives. So they are founded on that political objectives, as you can see them here. So the fighting the climate change, improving the energy security, guaranteeing the competitiveness and growth, and phasing out the nuclear energy. And as we have heard before from His Excellency Hans Knudsen, there's still, and maybe more than ever, within the focus of our things that we would like to do. And so is also the Energiewende based on these political objectives, but not just on these 4 political objectives, but also on 3 primary goals, which we would like to achieve in that Energiewende, in the transition of the energy usage, which is, as you can see it here, environmentally sound, secure and reliable, and affordable and cost effective. So all the things that we would like to do within the Energiewende should serve these goals and should bring us nearer to these goals, which is not so easy task in all the things, because sometimes we have to do more in the realm of one of the affordable. Sometimes it's more costly in the beginning, but later on then it's better. And you will see in my presentation that it should pay out, and it can pay out. So saying that these primary goals are in there, I would also state that the energy transition itself is focused on 3 principles, which is the energy or the efficiency first, then the direct use of the renewable energies, and also then the sector coupling. And these not just give us 3 principles, but also a kind of, say, which one is the first one to achieve, because there are priorities also. So the first thing is to look into the energy efficiency. And this is especially then for the buildings, which is the topic of my talk today, that we go into this energy efficiency enhancement in the buildings. And saying that, it's crucial that we go into and say, okay, what is energy efficiency? How is it defined, and what is the basis for that energy efficiency? And I have brought you the definition of the energy efficiency in the buildings, which means first a lower demand, and then high effectiveness in the energy generation and delivery. Which means we should focus in the beginning to that area that we say, okay, we not go into it and say we go and have better heatings or so on, but we first go into and say to diminish the demand of the buildings that we would like to build, and then we put in very good and very high effective energy generation, energy distribution, and deliveries. Coming from that and saying, okay, this is the basis, the definition of the energy efficiency, where do we want to go with that? So I have stated in the beginning that we say, okay, the basis is the 4 political principles. We want to reach 3 primary goals, and we want to do that on the 3 principles by that definition. But what is actually the numbers that we would like to reach in Germany? And this is displayed here on this graph you can see here. So there are 3 main objectives that we have. So we would like to reduce the greenhouse gas compared to year 1990 by 2050 due to 95%. And so we can go through, we would like to have more foundation of renewable energies within the electricity, and so on and so forth. And you can see the goals are very high. And comparing these to the goals or the achievement that we have in 2016, which are the numbers I have put in here, because the newer numbers are available, but not in that area, in all the areas that we can see them here. So we can see that we are in some areas quite good in that. So we have reached, for example, in the greenhouse gas reduction by 2016, almost 30%. Nowadays, coming to the 2020 year, we should be at -20. We are not there yet, but it's close to that. And we see also that there's a lot of things going on, especially in the primary energy consumption, that we are not in the realm of really these goals that we would like to achieve. But we are on the way, and we have done a lot in the direction of achieving these goals and really reaching these goals also in the end. And this would be the next slides I would like to show you in that direction of the energy efficient buildings, which is then the milestones that we have in that buildings achieved in Germany. And this is a graph which indicates what is in the regulations, what new buildings have to have or have as a maximum on energy, on primary energy demand. And you can see it's starting from the 1970s and now reaching the 2020s. And you can see that we have come from 450 or 430 kilowatt hours per square meter and year primary energy heating demand from that buildings in the 70s till the 1950s to now regulation. New buildings are about to have lower or at the maximum 50 kilowatt hours per square meter a year. We have reached that in Germany due to reducing the demand. So we are still on the demand side. We have not spoken about, have not a lot spoken about the energy generation or the usage of the energy, because you can't reach that just by having better equipment in the building. But we reach that by diminishing the demand of the energy. And contrary or in addition to that, you can see the lower graph here, which is indicated or which indicates the inventions, the researches in that area, which is actually looking at the plus energy buildings. So we are not looking into the buildings as consumers, but we're looking into the buildings as, producers of energy. And I will come to that point later on also, because this is at the moment not anymore in the research area it's coming more and more to the normal buildings area where we are in that. And following this development in which we compare the goals to that what we have done before, we also looked into some developments which shift our focus from just the demand side on the usage phase back to the construction side. And this graph shows you that we're looking more and more not just into the energy demand, but we're looking more and more into the global warming potential of the buildings. Speaking of the life cycle analysis, which is due to the fact that in a normal new building or in normal buildings, the energy consumption or the global warming potential of the building is to 80% or more than 80% during the operational phase. Now coming down to buildings with a demand lower than 50 kilowatt hours per square meter in year, this changes because then the operational time is less than 50% of the global warming potential, which is in that operation phase. And the construction phase is more in the focus because the more global warming potential is in that. So we have to look more and more into the back to the construction. What kind of materials do we use? What kind of possibilities do we put into that? And this is, and also how could we reuse that? How is the construction phase? How is the demolition phase or the reuse phase, cradle to cradle and so on? So this is a shift in looking at the buildings and looking at the energy efficiency, because it's not just the energy efficiency, it's also the resource efficiency. What kind of resources do we use? And stating that, it's also about the area of using it. So it's a combination of the usage, the construction, and what we also see in the energy efficiency discussion is that we are also going more and more into the direction of the operation monitoring, because the design and the construction, the demand calculation is the one phase, but the reality sometimes is another phase. And you can see here in the right graph the identified performance gap that we see in different buildings. So we really make very good building, we design them very good, and then we also build them very good, and then people moving in and using it, and we see that the energy usage that they have, the energy consumption that they have are sometimes, and as for the example of the office buildings, is more than 150% higher than that what we expected them to be, which is mostly then, as we see it, and as we discovered that the facility is not really a good worked. So we have to look into the building facility to bring really the facility in that mood as we predicted it in advance. So this is one of the fields, or two of the fields, that we are looking into at the moment. So the one is the materials itself, and the other one is how to close the performance gap between the design and really the performance itself. And we're doing that and learning a lot, looking into really good projects and high-end projects, which I've indicated before, which are also the plus energy buildings. So within the Energiewende, we are also into that area, which I stated before, that we go from the energy efficient or the low zero energy building to the plus energy building, to the building as little energy producers. And we learned a lot, or we still learning a lot in the realm of the performance gap that you see. And in that, if you're interested in that, you can look into the plus energy network, for example, where we have a lot of plus energy buildings which we are monitoring, which we look into and say, okay, what kind of building is it, where is it, and is it really per definition Effizienzhaus Plus, which is the German name for it, or is it just producing energy but not as much as it should? What we are learning out of that is that what I've told you before, that there's a lot of emphasis now in the area of construction techniques, reusing of that techniques, and we're still learning a lot. And also see, as you can see, a map of Germany and the buildings that we are looking into, where these buildings are located, how different they are in terms of where they are located and how they then are built, because there is a lot of differences in the surrounding climate, and the buildings adapt to that. So this is the one thing, and the other big issue that we have in the Energiewende, which is coming since some years, is also the look into the existing buildings, because we see that the existing buildings are having, from mere numbers, a bigger share in the building stock that we have, or in all over the building. So it's 77% to 23% from new buildings. But if we look at the energetical area, then we see that we have diminished the new buildings to a share of 5% of the energy consumption, and still the existing buildings are very high in that area. So we have to look into these buildings a lot and see what can we do in that to really push the Energiewende to the front. And saying that, the target, also the target for the energy mix for that, and here we are more or less in the area of the building energy production. You can see here the heating and cooling. So we have to go here deep into not the first to diminish the demand, but going deep into the high effectiveness of the energy generation and delivering in that area. So it's a combination of both. In all the areas, in the new buildings, it's more the diminishing the demand. We also do that in the area of the old building, but most of the old buildings, one of the first thing is that we also go into the effectiveness, or the effectiveness of the energy delivery. And a lot of innovations have been done in that area, depending on or linked to all these aspects. Just some examples for that. So there are a lot of new innovation building materials. There's also a good possibility to recycle old materials, but also, and there's a huge potential in a combined digital and real, we call it digital twin construction methodology, but also in the building operation, and also in the conversation of the energy in the grid, in the neighborhood, how to distribute the energy, how to use energy or waste energy from maybe facilities in as heating source for other buildings. So there's a lot to do in that area. And I would like to focus in the end, as I stated in the beginning, also in the direction of how to transform these energy efficiency measures, or the goals that we have reached, into other regions. And I would like to show you one picture of the key energy transition pathways. So as I said before, the first thing is always the building, the planning, and to reduce the investment cost and reduce the conserving. So going into and energy optimize the building, which is on the left circle of that diagram, and then go into and do an energy efficiency system and use renewable energies. And on the other hand side, if we are going into the operation, we need user-driven needs, which first of all go into the safety of the climate, and then go into the standby climate and a comfort climate, which is the end of that. And not just overall, but for each individual itself. And if we have done that, we are not finished with that, because this process is not just for once and for all. So you not just put in that once and then it's it. We have, or if we look, especially then for Latin America, if we look at the different areas we have different climates. We have different people living there, maybe not that diverse as you can see it in the picture here, but we have different cultures, and out of that, there should be adapted or different buildings for the culture and for that specific climate. And this is what we would like to, or what I would like to state in the end, that we try to have the most efficient and most effective buildings that we can have, but they should be built alike, that this is actually in the end the building that supports the environment, but also, and that's for most, the people living inside. And yeah, so this is the goal for all what we are doing, to save the living that we have and bringing that possibility also in other realms. So far from my side, if you have questions, I'm happy to answer them. And if you would like to contact me, you can see here also my contact data. So thank you very much.
Okay, thank you, Dr. Schmidt, for this wonderful presentation. I think we could all learn a lot about energy efficiency in buildings from the building physics perspective. I think it was a very impressive presentation that you gave us, and I personally liked a lot in the ending your cultural touch, that you also build a bridge towards the Latin American audience, saying that buildings are different in different environments in different countries, and they also kind of reflect the people who actually live in them. I think that was a very nice ending. I would like to read one question that I have received towards you. This is, what should be the main focus of Latin American companies and municipalities who seek to improve energy efficiency in their buildings?
It's not an easy question. How much time do I have to answer that?
I think you can take a minute to do so.
Okay. So I would say it's the best thing is really to look into the buildings and see what kind of possibility is there to really reduce the demand, which means, or which could mean on the one hand side, to implement some insulation, because then you will need lesser energy for heating, but also for cooling. If that's possible, it could also mean, as I stated in the pictures in the end, from the existing buildings, that you start with the new heating system or a new cooling system, because the system you're using is not really efficient and not really good. But this would always be the second choice, because if you can diminish the demand, then maybe also an old heating system is sufficient. Because you don't need that much energy, and it could be more sufficient. But it's very difficult to say in general what is the best thing to do. I would really start with the building itself, and I would really start with looking at diminishing the demand, and then going for the other goals.
Thank you so much. I think that is a very nice summary to say, take a focus on the diminishing of demand. But of course, we also see that it's a complex topic. And I think it's also good to see that there's like a lot of different opportunities to tackle energy efficiency. And I would like to say thank you once again, also to the audience. Our session is recorded, so if you want to follow up later with Dr. Schmidt, you can scroll in the presentation once again to find his contact details, and maybe we can set up today, like, give a little step into a relation between Germany and Latin America, and following up on this presentation later on. Now I would like to give the stage to the next speaker, who is Susanne Theumer. And she is an architect and is also a certified passive house consultant at the Passive House Institute here in Germany. Susanne Theumer, I would love to welcome you here on stage. Would you please turn on your camera?
Hello.
Hello, welcome. Nice to see you.
Do you also see my screen?
Yes, we can see your presentation very well.
Perfect.
Yeah, perfect.
Yeah, thank you very much for the invitation to present at this virtual fair. I would like to start with a short introduction about the Passive House Institute and the work we do. The first slide shows the different climates, and as we just heard, the measures in terms of energy efficiency always need to have the climate in the focus. That means the solutions need to be adapted to the specific climate zone. If we, for example, look at a passive house in Mexico, this means that the 5 passive house principles, continuous thermal insulation, continuous airtight layer, very good windows, thermal bridge-free design, and an adequate ventilation strategy look quite different to, for example, a Central European climate or a climate in Chile. Here, a simple extract air system was installed, and still the house could be certified as a passive house. The Passive House Institute does not only work in the European context, but we, for example, also work since more than 10 years in Mexico. We did several studies. We participated in the NAMA for new housing and existing housing. We developed a tool for social housing similar to the PHPP, the Passive House Planning Package. We consulted on a couple of built passive houses in different climates in Mexico, and we are currently providing technical input and webinars for different stakeholders in Mexico regarding the step-by-step implementation of the so-called ENERFIT standard, which is the retrofit standard with passive house components. The LAIF component is at the moment, in my opinion, the most interesting for this for the Central American market. Therefore, I want to show how we worked. We gave technical assistance, and the goal was to achieve passive houses and at the same time a reduction in CO2 emissions of a minimum of 80%. Sometimes that was in addition with renewable energy, mainly photovoltaic panels. And in parallel, of course, through the passive house standard, we increased the interior comfort for the end users. And so the houses are climate resilient, and also in the long term, there is no need to install, for example, additional air conditioning systems. The developers who participated in the program got 70% of the additional investment costs and the technical assistance for each of their projects. In such a pilot, it's always not a single person that is important, it's a team. And in this team, together we achieved the functioning of those houses, including the passing of the so-called blower door test, the air tightness test. We also helped to create supply chains for those new technologies which were not on the Mexican market. And we trained various levels, from the builders on site to the planners and also the energy consultants locally. Projects can be seen and will undergo a monitoring in future, hopefully starting next year. Here you can see the different climate zones and the cities. To stress the importance of the adaptation, so the building physics do not change worldwide, but how the houses look like in the end, that depends very much on the climate and the context. So I want to show you two different houses. They're both in Mexico, but the solutions are different to achieve the same high efficiency standard, the Passivhaus standard. This is for new buildings. So we used in the warm temperate climate an uninsulated concrete slab, and single glazing was good enough. And as I mentioned before, also an extract air only ventilation system. While in a hot and dry climate, we needed the triple glazing. We needed to insulate also a little bit the floor slab. But then we also compensated through those measures to only install an extract air system only, in combination with an air conditioner. In a large scale and as a top-down approach, we have seen and monitored the, at that time, largest Passivhaus district in the world, the so-called Bahnstadt Heidelberg. Heidelberg, the city of Heidelberg, started with several pilot projects in the city before they decided to buy this area, which is the so-called Bahnstadt. And as you can see, it's in the close vicinity to the city center of Heidelberg, the Altstadt, and also it is bigger than the city center. This is entirely Passivhaus and with different uses, including offices, hotels, kindergartens, and of course, several multifamily houses. Here are some impressions of the development. This was in 2012. In 2014, you could already see the buildings rising. And in 2015, even more. And a monitoring over 2 years showed the good results. We can prove that not only the houses are functioning, but also that the prediction with the tool PHPP in average is a good prediction. So you can actually use it as a tool to plan high efficient buildings. How we do that? It's, as I said, always the same 5 key principles: continuous layer of thermal insulation, high quality windows, sometimes triple glazing with insulated frames, sometimes single, sometimes double glazing, an adequate ventilation strategy. This could be a ventilation system with heat recovery or with heat and humidity recovery, or just an extract air system, a continuous air tightness layer, which is usually a big challenge because it's a new topic in developing countries. At the same time, it's often also quite easy to achieve because the materials already used in construction, mainly concrete, are airtight as such. So it's just a matter of combining the window, the airtight window, with the airtight concrete wall, and making sure that also the connection between the roof and the wall is airtight. And thermal bridges, the good news is that in warmer, hot and humid climates, the thermal bridges have a different effect. In some of those climates, it's enough to have a thermal bridge reduced design. It doesn't have to be a thermal bridge free design, because the thermal bridges are not as important as in a cooling, in a cold climate. To show you some examples, in different climates, there are factories in the Passivhaus standard. On the left-hand side, you can see a factory in China, in Harbin. And on the right-hand side, a retrofit with Passivhaus components in Sri Lanka, where the same principles are used. And there's a video available on YouTube. And looking at the various tall buildings, there's a competition going on. But as you can see, the first building shown here in 2010 was a residential tower in Freiburg in the south of Germany. And others followed in Spain, in New York, in China. At the moment, the highest one is the Chinese residential tower. Important in warm, hot and humid climate is to have a good summer comfort. It's always important also in German climates. We know very well how Passivhaus standard can reduce the energy demand for heating, but to have a summer strategy is of course important in Germany, but it's crucial in those warmer climates. The easiest strategy is external shading. And in addition, the external shading can be applied in various ways, flexible in a combination, as we can see here, with a balcony that shades the windows itself to allow the summer comfort at the same time as bringing light into the flats, and the users can enjoy the views and do not sit in the dark. What is going on in warm climates? Spain is at the moment on the Passivhaus forefront, with the Passivhaus kindergarten being currently constructed in Burgos. And here the same principles apply: external shading and using bioclimatic principles in combination with the Passivhaus principles. So Passivhaus standard does not mean that other proven techniques like bioclimatic design, like using natural materials, cannot be done, or renewables. It's the opposite. It's important to have a good combination. We actually will start a campaign about high efficiency called Efficiency, the First Renewable. So here we see more examples. We discussed this in advance of the presentation, and for Central America and Latin America, one typology is important, which is schools and kindergartens, as we have just seen, but also hotels. So here we can see different types of hotels. They have all something in common. They are all Passivhaus certified. We have as well retrofits in this list, but also new construction. I want to highlight two of them. One is the Hotel Arima, located in San Sebastian in the north of Spain, with a treated floor area, so the living area, of approximately 8,000 square meters. It was built a couple of years ago and certified in 2019. It's overlooking the Bay of San Sebastian, so surrounded by trees. And it's a nice new construction. But on the other hand, also in the north of Spain, but further to the west, in Adisana, there is a very typical building. It's even protected. It's a heritage building, which was converted from a residential building into a hotel. And this was done again using Passivhaus principles. It's certified under the ENERFIT seal with, in this case, internal insulation. Ideally, we always apply external insulation if possible, but in this case, if you have a protected facade or some other aspects, then there's no other solution than going for internal insulation. But they could nevertheless reduce the energy demand for heating by 95%. And the rooms, etc., everything looks very inviting. So when we all get a chance, then the possibility to visit this hotel is there. On the other hand, Spain is interesting for Latin America because also bigger blocks of apartments, for example, this social housing project in Getafe, near in the outskirts of Madrid, was recently certified as a Passivhaus. Again, external shading devices, external balconies that shade the windows. It's at the end of the day, same principles, similar procedures. And this was also presented at this year's International Passivhaus Conference and documented in the conference proceedings. Also, you can find more information about each of the projects that I have just shown in our free-to-use database. This is not an official database that lists all Passivhauses, but it's an offer from the Passivhaus Institute and our associations for dissemination, IFA and IG, to bring to a broader attention the buildings built under the standard. So you have always the ID number and you can search by country, by ID number, by name. Here's some more pictures of the same building, the social housing building in Madrid. And another project that was shown at this year's conference was the first Passivhaus certified in Saudi Arabia. Interesting enough, and very interesting also for from the scientific point of view. It was built next to a standard house or a conventional house in terms of energy efficiency, and then on the right-hand side, the same house but with Passivhaus principles and certified as a Passivhaus in this hot and dry climate. And a building that is already a little bit older. It's from 2009, but nevertheless, I like to show it because it's a nice blueprint. It's a small unit, single family house in the outskirts of Tokyo. It's in an interesting climate. It survived an earthquake, and it's built with natural materials, with timber. So it's a nice example. Also in India, the Passivhaus Institute is active. We are consulting and making a study for 5 cities in 5 climate zones regarding 5 efficiency levels and including various prototypes and also the Passivhaus standard level. And currently, the large settlement in Qingdao, a residential settlement, received the Passivhaus Classic certification. Classic because that depends on the amount of renewables. So if we have more renewables, we call it Passivhaus Plus, and if we have more renewable energy generation than the house actually needs, so we could also feed back to the grid or connect an electric car, etc. We call it Passivhaus Premium. And we hold an international Passivhaus conference every year since 1996, when the Passivhaus Institute was founded. So next year we are in North Rhine-Westphalia in Wuppertal in September, hopefully all in person and not virtual like this year. And I would like to draw your attention to this international event. And thank you for your attention, and I'm available for questions now, but also by email. You can contact me via susanne.theumer@passiv.de. Thank you very much. And with this, I hand back to Silke Jensen.
Yeah, Susanne Theumer, thank you so much for this wonderful presentation. It's impressive to see that you really have experience from around the world, that you worked in so many countries. I also think it was nice to see that you have quite some experience in Central America, that you worked a lot in Mexico. So I think this is very a nice addition to our conference here today. I have received some questions. They were sent in the chat, and I'm making a guess that they refer to your slides number 23 and 24, when you were talking about an example house in Madrid in Spain. Yeah. So the question is written, okay, I'm going to read it out to give the original voice. I sit in a wooden house. How about natural venting instead? How did you dry that own and using inner insulation?
So if I understand correctly, the question is how to have a good indoor air quality using different means of ventilation. So
I think so.
The principle here is in a time when the outside conditions are not so favorable, to rely on the hygienic needed air change rate to allow for always fresh air inside the building using a controlled ventilation system. But as soon as the outside air is fine for ventilation, to use the window ventilation as we always know it. So for example, at nighttime or in the evenings when it gets colder, or when it's also not so noisy outside, to use the window ventilation. For big cities like Madrid, where they have a high pollution, but also a high noise level constantly, I don't know if you know the saying, Madrid never sleeps. It is true. So in some cases, it's just not feasible or possible to use natural ventilation, or in a climate which is so humid, not in Madrid, but in a different climate where it's too humid most of the year, that you cannot bring in the humidity into the room. You just want the fresh air, but the humidity should stay out. Then it's a good idea to introduce a controlled ventilation system. In this particular building, they used a decentralized ventilation system. So every flat, every family has their own ventilation system.
Mm-hmm. Thank you so much. I hope that this question was answered well to the person who asked it. Thank you so much for taking the time. And I also would like to mention once again that I appreciate a lot that you took part in this conference today. Thank you so much. And if there's more questions to Susanne Theumer, she was also so kind to show her contact details, and she invited also the Latin American and German audience to a conference next year. So I really keep my fingers crossed that this will take place in a real live event, and maybe today some people can write down already the date and follow up on this. So we have a follow-up in the future that is face-to-face. Thank you so much once again. I would like to turn then to our next speaker. Thank you. Bye-bye. So Giulia Peretti is our next speaker. She is an architect and currently the team leader for building physics and sustainability at the German company Werner Sobeck Green Technologies GmbH. She is also a DGNB auditor and an expert for sustainable building. It's very nice to meet you. Welcome to the ExpoVirtual.
Thank you very much, Silke. I hope you can hear me.
We can hear you very well. We would also invite you now to share your screen.
Yes, one moment.
Perfect. Okay, then the stage is yours.
So thank you very much. So I will not go in detail about myself because a brief introduction was already done. And I'm very happy to be here and to talk about sustainability building certifications and how this certification can promote the implementation of sustainable buildings. So my presentation will be structured in 5 points. The first one is a brief introduction about the company where I work. And the second point is about the importance of certifications. And then I will go a little bit more in detail about the German sustainability certification system, which is called DGNB. And then at the end, I will show you a couple of examples of sustainable buildings which have a high rating in the certification system. So the company Werner Sobeck is a German company founded in the 90s. We are worldwide about 350 people, and we have offices worldwide, including one in Buenos Aires. And the services we have covers all the engineering disciplines, facade and structural, but also MEP systems. And in special, where I work is Green Technologies, which is the branch of Werner Sobeck dealing with building physics and sustainability. We have many different projects worldwide in Germany, in Europe, but also in Kazakhstan, Azerbaijan, for smaller buildings like the one in Zurich, but also very large buildings like the development for the Expo. Here are world map of where we are, and you can see that most of our projects are indeed in Europe, but we have also some projects in Latin America. So now going into detail on the topics of this presentation is why certification matters. So why is certification a driver for sustainability in the building industry? So sustainability buildings are often seen as or considered just as a marketing tool or a sticker. But certification are definitely much more than this, and are most of all a successful and recognized as an instrument for the improvement of the quality of the building. So many systems are indeed focusing on environmental and energetics aspects, but the new certification system covers all the fields of sustainability. So certification are a good tool to strengthen the sustainability agendas in a project. So they are a comprehensive design tool for creators and also a valuable verification tool for investors and owners. So sustainable buildings is therefore a value driver and not a cost driver. Finally, certification gives the possibility to measure and to compare the sustainable performance of buildings by applying a set of quantifiable criteria. There are many aspects which can be considered, or many benefits when we are dealing with a certified or a certification process in a building. So there are benefits for the users. So this means that the quality is higher, the comfort is for the user is higher, and the operational cost, so the energy demand is lower. So the operational costs are lower. For the investor, there are also benefits because he has a building with a higher value and therefore a lower risk in a longer time schedule. For the designer, our certification are an efficient tool for integral and targeted design. And especially in the new system, there is a large part or a large possibility for a promotion of innovation. They are an instrument for the quality control because you have a set of criteria and which are approved from an independent certification body. And also the marketing instrument or the marketing benefits is pretty high because they are a pretty well-known system, so it can be used also as a communication tool. Worldwide, there are very many certification systems throughout the world. Here in Europe, we have many different, but the system where I'm going to discuss today is the DGNB system. And I will go through the background and a bit on the focus on the special topics of this certification system. So DGNB means Deutsche Gesellschaft für nachhaltiges Bauen, which translated in English is German Sustainable Building Council. And it is a no-profit organization which was founded in 2007 in Germany. Nowadays, it counts about 1,200 members and is growing pretty fast. So to make the sustainability, to implement sustainability in the building structure, in the building market, they developed a certification system, and the first project has been certified at the end of 2008. And since then, there are about 6,000 certified projects all around the world. And here in Germany, it's the market leader for the new constructions. There are many different profiles and stages of the buildings that can be certified according to the DGNB system. There are, for example, pre-certificate for new construction, but there are also certification for building in operation, also building in use. In the case of renovation or conversion, and a pretty new type of certification is the dismantling certificate for end of life. The types of building you can consider is very different. So from office, healthcare, retail, educational, but also the dimension. It's possible to certify building or larger districts, urban districts or industrial areas, for example, but also smaller project and only interiors as well. Like many other systems, the award level in the DGNB system are the classical bronze to platinum, although the bronze certification is only for existing building and building in certification in use. So for achieving one of the different levels, you have to reach at least 50 or 65 or 80% or higher. But there is also a minimum performance index that you should achieve in order to receive the certification. And this point is done in order to provide buildings which are good in every category and not only in one of the categories which are investigated by the DGNB system. I will speak a little more in detail in some slides. Furthermore, there are two additional certifications. The first one is the Diamond certification, which is a special award for the architectural quality of the buildings. And this award is provided by a group of architects which evaluate the architectural quality and the shape of the building. And there is also another certification for climate positive buildings, and can be awarded to building in operation which are carbon neutral. Which are the unique selling proposition of the DGNB system? So as you know, there are many different certification systems investigating many different aspects of the built environment. So as you can see in this picture, it's pretty interesting because you can see that most of the well-known certification, they do focus on environmental aspects. So certifications like LEED or Active House, they really focus on the energetic and environmental aspects. The German certification, the DGNB, is the only one which has a balance between many different aspects of the sustainable building, and mainly so the common and traditional three pillars of sustainability, also environment, economic aspects, and social aspects. And this is one of the special features of the DGNB system, which is this holistic approach covering all the important aspects of the building. The second point is the life cycle approach. So the building is investigated throughout its entire life cycle. this means from the construction and the production of the materials up to the end of life. And the third point is the performance orientation. So the focus is on the overall achievement of the sustainability goals and not the way you achieve these goals. So you are pretty free on the measures you want to use to achieve a certain sustainability goal. Here you have an overview of the different criteria integrated in the systems. So the first three are the pillars of the sustainability: environmental quality, including everything which is related to the impact on the environment, from the use of materials up to the energy efficiency. Then economy, which is based on the life cycle costing over 50 years, but also a very important point is the flexibility and the adaptability to changes of the uses. Then in the social topics, we found everything related to the comfort, but also to the safety for the users. Then there are technical criteria related, for example, to the building physics quality, thermal and acoustic, and noise protection. And the last two categories are the quality of the process. So this means how the process of founding the design solution, as well as the construction stage and the operation of the building. And the last one regards the location of the building and its integration in the context. How does the sustainability, the DGNBS system promote sustainable building? So in 2018, it was released a new version of the DGNBS system, and it has a focus on 4 points. And the first one is using the life cycle assessment as a tool to improve the design. So it's a very large point to deal with the decarbonization of the world. So in the system helps to or the use of renewable resources and energies. Furthermore, through the LCA, there is a possibility to improve the energy efficiency and also the efficient operation of the buildings. The second point is the life cycle costing. So you receive points if in the project are integrated design solution for the reduction of the operational costs in terms of cleaning and maintenance. And on the other side, there is a focus on the minimization and balancing the costs over the entire life cycle. And the other 2 points, which are very important, are the circular economy approaches. So in the new system, there are bonus points for design solution which support circular economy, like so the reuse of material or design for disassembly. And the fourth point are the focus on health and comfort for the users. So one of the very important points for the beginning was the use of low emitting material and highest air quality inside the building. And this is assured through quality measurement, air quality measurement at the end at the completion of the building. And furthermore, there are many criteria which focus on the good thermal and visual and acoustic condition for the users. What is important also for you sitting outside of Germany is that there is an international version of the DGNBS system, and it is basically an adaptation to an international context of the criteria, of the core criteria of the DGNBS system. And through the use of international standards for the evaluation, it is possible to apply the criteria of the DGNBS system also to building all over the world. And this is very helpful because there is could be a consistent overall quality that can be ensured. And there are adaptations regarding the climatic condition, the structural, legal, and cultural variation. And according to the country you are certifying, there are a small variation of the benchmarks. So far, there are no certified building in Latin America, but there is an existing cooperation of the DGMB with Argentina and Chile. And now, going to the end of the presentation, I would like to present two interesting projects which my office certified in the last years. The first one is a fair complex in Nuremberg, which is a city in southern Germany. And the Nuremberg Fair is one of the 15 largest exhibition companies all around the world. And in the year 2000, more or less, they decided to improve their exhibition areas. And next to a high architectural quality, and they went for a very high sustainability quality. So regarding the architecture, all the buildings were designed by Zadit. And regarding the sustainability, the goal was to achieve for all the buildings the highest rating, which is the DGMB Platinum. And indeed, this was possible. And for the first two halls completed in 2013 and 19, the platinum certification was achieved, and indeed these two buildings are in the top 5 in the highest certification ratings ever of the DGMB since its founding. So the first two halls were certified, both with a larger focus on the indoor air quality regarding the materials and the social aspects like the barrier-free. And the third building is a Congress Center, which will be built in the next about 5 years. And this building is in the design, and this year it received a pre-certification also in Platinum. The last building is a school in the eastern part of Germany. It's not a DGMB certification, but is the equivalent system for federal buildings and public buildings, which is called BNB certification. But at the end, it's more or less the same with smaller changes. And in this case, of course, the energy efficiency was one of the main points, but as this school has also an educational aspect, the social sustainability aspect were on the focus. And the three nice or very interesting points we implemented through the certification are the participation of the students. For example, we developed a contest between the students for the design of the toilets and other public spaces within the building through the use of colors tiles. And here you can see one of the development and the designs done by the students. Then the second point was the excellent indoor air quality, and in the building only certified ecological and low emitting materials were used, and there is a large use of wood, for example. And the third point is the user user friendliness of all the technical system within each room. And this was a concept developed together with the teachers in order to make easy accessible for all the control of the technical system within the room. Yes, and this was also to the end of my presentation, and I hope that I could give you a quite easy view into the German system, and it will be great to have the possibility to have more projects also in, or any projects also in Latin America. Thank you.
Thank you so much, Ms. Peretti. That was a very wonderful presentation. I think we could learn a lot about certification. And I also think you mentioned by yourself a very important aspect of certification, which not only applies for the building sector, but general for sustainable certification, that there's the question if this is really helping or it's rather a marketing tool. I personally agree that if you set standards, you also give a framework in which buildings can be improved or operations can be improved. I think this is very important. I would like to give you some questions also. So one of them is, how do you come up with the criteria and how do you measure them? Maybe you can explain a detail, like an example.
So there are many different criteria. For example, regarding the life cycle assessment, there are benchmarks which are different for the different typologies of buildings you are considering. And this is calculated through a life cycle assessment exercise. So you calculate for the old building, all the materials, the whole life stages of the building, so from the production of the material up to the end of life, and including also all the energy used for the operation. So, and this is calculated with with numbers. There are then other criteria with also qualitative evaluation. So there are many points you should fulfill. For example, do the building has shading elements? Do the building have external areas, and so on? So it's mixed. Many of them are should be calculated, and others there are criteria to fulfill.
Kind of like a checklist. So if you can take yes and no, then you will fulfill this criterion or not. Yeah, very interesting. Thank you. Another question I would like to ask you is, what do you think about the World Bank's EDGE, Excellence in Design for Greater Efficiency certification system?
I have no opinion about it. Sorry, I don't know it.
You don't know it. Okay, I think that's also an answer. Okay, and then maybe a last question. What do you think, how could German technologies improve sustainability in the building sector?
So in the building sector, I assume that you've been so in the worldwide building sector. So German technology, how can
be particularly in Latin America? I suppose this question was sent in the chat. So yeah.
So we saw in the last 10 years or 20 years since that for example, this DGNB certification system was a driver for the improvement of the companies and the suppliers. So I think that using also in Latin America products which have a high quality and a certified high quality here in Germany can be a good starting point also for Latin America. And there are many technologies that are now more or less standard here, and they can be used also in different climate zones, like so shading system and so on. And I think that the German market has a pretty good international availability. And so far I know everything is also available in English. So check what is available on the German market, and most of them can be used or ordered also for other countries outside Germany.
Perfect. So thank you so much. Once again, we really appreciated your wonderful presentation. I think it was very interesting. We could learn a lot. And yeah, I thank you so much. Wish you a nice evening. And I would like to introduce then the next speaker. This is Marco Schmidt. He is a research consultant and he works at the Federal Institute for Research on Building, Urban Affairs and Spatial Development in the Department of Energy Optimized Construction. He is also a researcher at the Institute of Architecture at the Technical University of Berlin. Hello, good evening.
Yeah,
nice
thank
to
you very
see
much,
you.
Ms. Jensen. Can you hear me? All fine?
Yeah, we can hear you very well.
Good.
And we would also like to ask you, is that your screen already?
No, it's from somebody else.
Okay.
Maybe somebody has to leave the screen and I can share mine.
Julia, could you kindly stop the screen sharing if you can still hear me? Perfect.
Yeah, okay. Now I will share mine.
Perfect. The stage is yours. Yeah, then you need to put it in the presentation mode and then.
Yes. Yeah, thank you very much for the invitation. I think you made a great work. All your team from Energiewende. Thank you for the invitation here. Yeah, as you mentioned already, I never left university. I still stay there, but greetings now at the moment from the Federal Institute for Research on Building and Urban Affairs. I'm in the office currently. We are working on plus energy buildings. This is currently the construction site where I'm working on. It's the environmental agency in Dessau. They receive a plus energy building. We developed the guidelines for sustainable building as well, which was mentioned by Ms. Peretti a few minutes ago. So it's a parallel system from DGNB. Quite similar. This plus energy building is quite interesting because we have lots of photovoltaic at the facade and on the roof. And we produce more energy than used inside of the building as well for all the coffee machines and computers and so on. This is currently the construction site. And yeah, I will come a little bit later to some topics of green roof combined with photovoltaic panels. The building is quite interesting. My topic is, I would say, energy efficient cooling in total. And there are 4 options available, which I will present here now. This building is, I would say, supplied with a common approach. It's geothermal use. We have 32 drills in a depth of 25 meters and using a heat pump of 53 kilowatt. It's a propane heat pump. So I would say quite new technology. Primary energy demand is quite low. And interesting now is the first measurement, the coefficient of performance for heating I measured there is about 4.38, which is quite okay. But interesting is now and important the coefficient of performance for cooling, because we are not using any heat pump from the geothermal side. We're using directly from the underground, and I measured about 26. So that's just the energy you use to pump the cold during summer from the underground and distribute it inside of the building. Of course, for Latin America, we have to think about where we are. So I would say compared to Germany, this might not be everywhere an option because the temperatures in the soil are higher. But I will present you 3 more options. And as well now the question is how you distribute the cold inside of the building. So it can be activated concrete, for example, like in this case, but you can use as well an air circulation inside, which I will present later. So this is version number 1. I'm working mainly on ecological construction. So I don't want to concentrate just on the aspects of kilowatt hours and carbon footprint. The topic on ecological construction is more, and that's what DGNB focuses in, and as well the BNB certification system. One topic is the topic of water and climate change. So in the neighborhood of this environmental agency in Dessau, you will find the river Elbe. And if you look a little bit closer, this was 2 years ago. It was quite dry. It's getting drier and drier in Germany, like in Latin America. It's the same worldwide. And you can see the bicycle in the ground. So there was no runoff out of this water catchment the last 2 years, nearly nothing. But as you can compare here, in the year 2002 and 2013, there was a huge flood. And everything is interrelated to this topic of climate change. So we dry out currently. And one of the main reasons is that we don't evaporate water enough anymore on land. This happens worldwide. So the last pictures you received by television came from, for example, the Amazon rainforests, then Pantanal in Brazil, but as well United States and near San Francisco. We have worldwide the problem then if you dry out the remaining forests, they will burn down because it gets drier and drier in the soil. And I'm living here at the border between Berlin and Brandenburg. This lake receives water from the groundwater level. And we lost the last 25 years, about 10% of its volume. You can see the boat here. So there's about 1 meter missing meanwhile. So our landscapes are drying out. And that's why sustainable construction should not focus only on the topic of energy efficiency and energy consumption, but the option to improve the situation overall these topics. And that's why we founded at the university a Water G group. Water G means water and energy and green aspects to be included in a sustainable construction. At university, I would say we are mainly guilty that people who are leaving the university are too specialized. So lots of groups as engineers are just coming out university and they focus on the topic of water, for example, just water supply or wastewater treatment. Another group just focuses on ventilation systems, cooling systems, yeah, or energy supply, sustainable supply like photovoltaic systems. And a third group like landscape architects, they just focus on greening aspects, maybe just entering the building when the building nearly is finished and then trying to green just a bit. But what is quite important is that these bricks in between the goals, they're really huge. Yeah, so if you try to integrate these topics, you will come to the solution that, for example, the evaporation of water and the condensation includes a huge energy shift. It's 680 kilowatt hours of energy shift if you evaporate 1 cubic meter. This is really large. If you compare what you can store inside of 1 cubic meter, if you heat it from 30 to 90 degrees, it's just 68. So it's 10 times more energy you need in the evaporation process. And you can use this process as well for heating in the winter time. If you dry, for example, a salt solution, what we do in our prototype here in Berlin-Dahlem on the left side down. We dry a salt solution in the summer and use it in the winter to absorb water vapor, and then you regain the 680 kilowatt hours without any loss. Yeah, so it's like a battery storage without any loss, and you don't need to insulate that. On the right side down, this is our prototype in Spain. There we focus on another topic. There we recool between day and night and try to regain the evaporated water in a crop production in a greenhouse. As well, on the global side, the evaporation of water is the dominant factor. It's much larger than the shortwave radiation. This is and long-wave radiation from land. Shortwave incoming radiation is 4.4 kilowatt hours per square meter. A certain amount, so it's about 10%, is converted to reflection shortwave. Huge amount is long-wave emission. But the most important aspect is always the evaporation of water of 1 square meter. And just a small amount will be converted to sensible heat. This we call convection as well. Evaporation is about 45%. What is now going on if we look to urban areas? Urban areas are dominated by sealed surfaces, no vegetation, and you shift the rainwater directly into sewers, so the rainwater disappears in the underground and then into the streams. And therefore we have to convert all the incoming radiation, like here in the summer months in Berlin, from an asphalt roof into sensible heat or increased thermal radiation, so increased surface temperatures. And this process is ongoing. So we lose every day about 800 square kilometers of vegetation worldwide. Urbanization is about 150 square kilometers. Forest, we lose about 350 square kilometers worldwide. That's why I'm absolutely against the use of biomass currently. For example, wood pellets for heating, because this is part of the problem and not part of a solution. Daily global desertification is about 300 square kilometers. So it's about the size of Berlin we lose every day in vegetation worldwide. And that means that we shift 800 square kilometers daily from the upper left energy budget to the lower down energy budget, more or less. And this we call the urban heat island effect. In my view as well, this is part of the cause of global warming. As well, if you don't evaporate water anymore, you get no precipitation. That's why we dry out in our landscapes. And that's why we need to focus on evaporative cooling as well in buildings. So we have to divide between the large water cycle, that means evaporation of water from the ocean and precipitation on land. But most of the precipitation we get on land, for example, here in Berlin-Brandenburg, is not coming from the Atlantic Ocean. It's evaporated water already from the catchment from France, from Spain, from Brandenburg. And on the global scale, we underestimate the amount of evaporation. So evaporation in our landscape here in Berlin-Brandenburg is 80%, and just 20% is runoff from the rivers and streams. So our main goal must be, if we create a building, that we need to compensate the environmental impact and try to recycle the water we use inside of the building and the rainwater we get, and use it to convert it into the evaporative process. We have another problem that we wanted to save energy in the consumption of buildings in Germany between 1990 and 2020 by 50%. At the same time, we expect an increase of 260%. It's even not the same time, it's the last 20 years. So it's quite clear that we get a conflict in goals. And if you look to a global scale, then the amount for cooling is already larger than the energy amount you need in buildings for heating. If you green, for example, a building, this is the same site, the same location where I measured a green roof compared to a conventional roof I showed you before. You convert already 2/3 of the net radiation into the evaporation of water. So during a year, if you just have about 8 centimeters of soil, you convert 70% of the incoming precipitation into the evaporation of water. And this has, of course, an effect on the rooms below the green roof. Yeah, this is just to compare the conventional roof in the neighborhood. Yeah, same incoming radiation, but the conversion of 2/3 of the net radiation already into the evaporation of water. If you look to the surface temperature of a conventional roof, during night it might have about 5 degrees, during day 55, goes up to 60, 65 degrees if you have a black asphalt roof. And of course, this enters the building just as long wave radiation if you measure the surface temperature infrared. So the goal's temperature inside of a building is about 26 degrees in the summer. And of course, the radiation enters if you have 55 degrees. It's the same as if in the wintertime transmission loss will be the difference of about 30 degrees. Yeah, so that means in the winter the goal is 21. That means outside air temperature of the surface is -10. So it's the same result. During night, of course, the opposite happens. So during day and during night, it will be nearly 0. But if you compare now the surface temperature of a green roof, this is a dark green line here, then it's always, no, it's a light green line. It's always below the 26 degrees. So that means that you lose the air inside, the air temperature, the energy. And that means you'll get a transmission during day of about at least already 60 watt per square meter at 10 centimeters of insulation. If you have less insulation, then the effect is even larger. That's why it makes sense to combine, for example, photovoltaic panels on a roof. So on one hand, the efficiency gets better if you cool a panel. It's really hard to measure this effect, and I'm not sure whether we have any effect. I would say maybe ventilation is more important than this long wave emission from the green roof. But on the other hand, you get a higher biodiversity from a green roof. In former times, this was the first time when we integrated a green roof with photovoltaic panels. We orientated the panels to the south. What we are doing now makes more sense to orientate east and west and to combine it with a green roof. Then we call it a butterfly construction. Yeah, this really makes sense because the rainwater needs to enter below and to distribute on the surface of the green roof and then provides evaporative cooling. We used here on the environmental agency on top of the roof semi-transparent models to provide a bit as well of radiation for the plants. And the durability of these panels is higher. What I'm evaluating as well is this building. It's the Institute of Physics of the Humboldt University in Berlin. Here we harvest rainwater from the roof and provide irrigation for 450 climbing plants in front of the glass facade. Yeah, they grow out of 150 planter boxes. And I would like to show you the results. And we use rainwater as well in air conditioners in the evaporation process. We call it exhaust air cooling. Never use electricity to cool a building. I would say it's quite clear because in the process of using electricity, you produce heat, exhaust heat. And this you emit normally in the street. So if you would like to produce 680 kilowatt hours of cold and you use 310 kilowatt hours of electricity as a normal COP for this system of 2.2, then you emit 990 kilowatt hours of sensible heat outside. always try to provide shadow and produce evaporative cooling at the skin of the building. This really makes sense. Some views on this building. We have 5 courtyards and about 9 facades which are greened and about 9 which are non-greened. And here I can compare then the results. What is quite interesting as well, when we measured the real energy consumption and compared it to the demand, which we calculated after our DIN 18599. So if you want to construct a building, you have to calculate the energy consumption. And there's a huge difference between these numbers, especially in the energy consumption for cooling. So in our modern buildings, you need much more energy for cooling in the primary factor than for heating in the winter time. And you underestimate the amount you need for cooling by about 640 to 800%. And of course, this is really a huge problem we have, because if you try now to optimize a building and the energy consumption for building, you would concentrate here mainly on the amount you need for ventilation. But in fact, if you compare it to the real measurements we carried out here at the buildings, you should concentrate on the amount for cooling. And if we would not have some efficiency systems inside of the building where we try to reduce cooling, it would be even higher. Of course, one problem is that we have too much glass, and we have more than 70%. But on the other hand, this is quite typical for modern buildings. So half of the building is covered with plants, and the results are really quite good. When I show it to you, we provide evaporative cooling of 280 kilowatt hours every day per each facade. Yeah, and of course, this happens outside of the building, but it provides as well a certain benefit for the energy consumption for cooling inside. Here, a nice view on one of the courtyards in the spring. For the first 3 groups of columns, we estimate the amount for a south-orientated office in this building as energy consumption for heating in red, cooling in blue, and in total, as if we won't have any sun protection system at all. The next group of columns is with conventional blinds, which are controlled manually. And what we really integrated in this building are conventional blinds, but which are controlled by conventional building controls unit. Yeah, and then here, what you can compare are the real measurements we carried out, and it's quite, in this case, quite similar. So here, the simulations are, I would say, correct, which they are not often correct, but here in this case, they are correct. So the energy amount for heating, for cooling, and in total. Quite interesting is now if you compare the energy amount for heating and cooling, if you compare it to the green facade, because there's no simulation up to now available. So you cannot simulate a building with some green climate plants growing in front of your window. And the result is even better. So you can save lots of energy amount for cooling. The increase for heating is just a little bit, it's about 10%, but for cooling, the reduction is nearly 50%. So it's a quite good estimation. Quite good result. The second amount is you won't find any conventional sun blinds where you evaporate water to produce cold. You produce always long wave emission inside of your building and hot air, so hot convection. And these are measurements of the surface temperature of the glass behind conventional sun blinds, and here behind the plants. And of course, they are much colder, and it's about 8 times less if you compare it to the goal temperature inside of your building. So the conventional blinds, they emit much more energy, long wave into the building than the green plants. Maintenance costs. So normally if you ask an architect, he will always talk about that the costs are much higher for maintenance if you have a plant in front of your building. We compared it, the both systems at this building. The Humboldt University pays every year about 16,500 euros for the maintenance and the repair of the conventional blinds. So 16,500 for water, irrigation, fertilizer, and maintenance. For the plants, you spend about 1,300 euro. You should spend a little bit more, maybe 2,000 or 2,500. But there's a huge gap between both systems, and that's really quite interesting. Yeah. So it's always under expected what you need to charge for conventional systems than if you are charged for a low-tech system, like a plant. So in this case, we have a 4-win strategy. So cheaper in investment, cheaper in operation, better performance for the building, and better for the environment. And now you have to ask why we lost about 50% of the green facades in Berlin the last 30 years. It's really a pity. So we are losing the plants in front of a building. So the opposite happens currently. So this is version 2, green roofs, green facades, and the coefficient of performance is not about 26 like the version 1. It's you spend really nothing. So coefficient of performance is you don't spend any conventional energy for the irrigation of the plants, or the we don't irrigate the green roof. Another option, so we are using rainwater in this case in this building in the evaporation process in the air conditioners. So we have conventional air conditioners in this building with supply air, exhaust air, external air, and discharged air. So, but we evaporate always in the discharged air. And we can reduce, for example, the temperature from the discharge air from 26 inside to 16 degrees. So you always get at least 10 degrees of difference in the evaporation process. We do it here, yeah. You just evaporate it in about a system of about 1 meter. And then we use external air. We cool it down in a heat exchanger. We are using always in the winter time as well, to not to lose too much energy. If you have external air temperatures of maybe 0, and then you exchange the heat or the cold, even now here in the summertime, and you can supply the building with 18, 19, 20 degrees without using any artificial cold. And now to compare the cost of 3 systems we have in this building. So the most expensive system is absorption system. So it's an absorber who converts hot water from a cogeneration system. In this case, we pay about 3.7 cents for the hot water. It's a central supply. But in total, we spend for 1,000 kilowatt hours about 160 euros. So that means 16 cents per kilowatt hours of cold. It's the most expensive way for cooling. Sometimes we call it solar cooling if you provide the heat not by a cogeneration, but by solar thermal systems, for example. But you have to be careful because you need lots of energy as well for the recooling process. And we have, Silke Jensen, I will just hurry up, yeah? Just the last slides. 21 euro as well for water in the recooling process, and you need lots of energy for the pumps. If you have a conventional compression system, you spend about 90. But if you look to the evaporation of water, you just spend €1. Or if you would have artificial water, it's about €7. That means 0.1 cent if you use rainwater. So it's a win-win-win system, cheaper in investment, cheaper in operation, and better for the environment. And this is version 3, adiabatic exhaust and cooling. The coefficient of performance is about 100 for the energy you need to pump water. And now the last version, it's just 3 slides. We use it currently in the TATS building and in the Böll. There we evaporate water on some pipes and we circulate. So it's an evaporative cooling, but it's not air-to-air system, but air-to-water system. Pipe in a stainless steel system. It's coming from Erich Keller from Switzerland, the system. And the cold water we are using then, and we use it here in these circulation units. And it's really a perfect system with a ventilation here. We have 3 systems of 50 kilowatts. It's 150 kilowatt for this building. And really interesting, there the coefficient of performance is about 25 to about 50. So some of the supply temperatures. So it's cheaper in operation, better for the environment, but unfortunately more expensive. So version 4, adiabatic circulation air cooling, coefficient of performance 25 to 50. So I would say the last 3 systems at least are really a good option for Latin America. Never use electricity, but you always do, I know. But this would be an option for your country. And if you have questions, just ask me, and we have some websites where we provide you with more information. Sorry, Silke Jensen.
Thank you so much. Yeah, I think it's a very interesting topic, and I think it's also nice to see that once you get passionate, you just let time go a bit. I think it doesn't really matter. It was very, very nice presentation. We could learn a lot. I think it's also a very striking picture of the green facade compared to a facade full of these air conditionings. Since we're running a bit out of the time, I would kindly ask the questions that were in the chat. We will send them forward to you, and you showed here some websites where you can be contacted through. So yeah, I would like to end with you as our last speaker of the first session right now. Thank you so much, and have a nice evening. And we will have a very short break now of 5 minutes. And after the 5 minutes break, we will continue with session 2, which is energy efficiency in the industry. So I hope I see all of you back in 5 minutes.